All right. So over the weekend, you guys should have made sure you had completed worksheets 1 and 3, and then numbers 9 through 12, I think, was the problem set. Did you guys have questions on any of those?
It was 5 through 8, right?
I think it was 9 through 12 or something.
Or
5 through 8's this week.
oh, that's
Yeah. Okay. Okay. And then last time we met, we had assigned 5 through 8 and then worksheet 5. Do you guys have any questions on those?
You do number 8.
On the 5 through 8?
Yes.
Sure.
Worksheet 1 we do last night. Worksheet 5 is
All right. So the directions for 7 and 8 say identify the function rule based on the graph. So basically it just wants me to write the equation for a sinusoid here, right? So a sine or cosine function, doesn't matter which kind. What I like to do is I like to start by identifying the midline. So that looks like the midline there at y equals 0. That tells me my value for k is going to be 0. The next thing I look for is the amplitude. Remember, the amplitude is the distance from an extrema, like this maximum, back to the midline. So if I count that, that looks like 3 units. And since the amplitude is the absolute value of a, that tells me a could be then 3 or -3. And then I'm going to use the period, or look for the period. The period is like the longest non-repeating piece of the graph. So I'm just going to count from maximum to maximum. That would be 1 period. So I started at 0 and I went to pi. And since I know a period is 2 pi times the absolute value of c, that tells me then the absolute value of c is either 1/2. Oh, I'm sorry. The value of c is 1/2 or -1/2. And we're always going to pick our c to be positive. So now it just comes down to writing either a sine or a cosine function. I have to choose which one I want to write. It doesn't really matter which one I would pick. I can do either. For the sake of argument, I'm going to pick a cosine function. So for the cosine function, I use the point 0, 1 from the parent function. And I'm going to map it up to some other extreme point. So if I look, I could use this one, or 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 this one. Those are all viable points I could use. This is the one Mr. Kulik would choose, just because the coordinates are easy to write. I note that that's also a maximum. Since I'm taking a parent function that's a maximum and mapping it to another maximum on my resultant function, that tells me the value for a needs to be the positive. And then since the parent function x-coordinate is 0, the x-coordinate from the resultant function is going to be my h. So that tells me my h in this case is also 0. And now I just need to plug everything in. So I have y equals 3 times cosine of 1/1/2 x minus 0 plus 0. And you could simplify that down if you wanted to 3 cosine 2x would be fine. but you don't need to. Leaving it like this is okay. Yep, you're fine. See you later. Good luck with your meeting. Others. Was this okay? I know that was Braden's question. Or Nathan's. Long person. Any other questions from the homeworks? Okie dokie. Well, let's continue on then. So today we're going to continue on in section 3.1. This will be the last day of content that we have in section 3.1. And the idea here is that I'd like to go from information about the graph to the equation. So if we think about what we've done so far in 3.1, we've talked about graphing sine and cosine functions, going from the equation to the graph, right? Last time we talked about going from the graph back to the equation. Today we're going to make this a little bit more difficult. And instead of giving you all the information about the graph, we're just going to give you some of the information from the graph and ask you to come up with the equation. Okay, so we're just going to go through and do some examples here. Oops. I don't know, do 2 or 3 of these examples, and we'll let you try some of these on your own. So here it said, the directions say, construct a sinusoid with an amplitude of 4, a period of 3 pi, and passes through the point 3,1. So when we ask for a sinusoid, what are we really asking for there? It's asking you to come up with an equation of either a sine function or a cosine function. Doesn't matter which, you can choose. So when we say sinusoid, that's really what we mean. So far, so good? Okay. Now when we say amplitude of 4, what does that tell us? So when it tells you the amplitude is 4, what does that tell you? What information is that telling you about?
Distance from the midline to the
yeah, but which correct? That's true. But what coefficient? A, C, H, or K? Yeah, it's telling us that the absolute value of A is 4, so we know that A is 4 or negative 4. Okay. Then it tells us the period is 3 pi. What do we know about the period? Yeah, so great, the period was 2 pi times the absolute value of c. So if I divide both sides by 2 pi, I get that c is 3 over 2. So c is 3 over 2 or negative 3 over 2. But remember, we're always going to pick our c to be positive when we're doing this. Everybody okay here so far? And then we're told it passes through the point 3, 1. Somehow this piece is going to have to tell us then the h, the k, and the sign on a. Whoa, Mr. Gulick, that's kind of a lot of information for one little thing to be giving me. Well, that's true, but it's okay. What we want to do first is we want to pick whether we're going to be writing a sine or cosine function, because the process changes a little bit here, depending on which one you choose. One of which is going to make the process easier, and one of it will make it a little bit more difficult. The one that Mr. Kulik would suggest choosing on a problem like this is the sine function. So we're told that it just needs to pass through this point 3, 1, right? We're not told specifically whether 3, 1 has to be like a midline point or a maximum or a minimum or some other kind of point. Everybody agree with that? All we need to do is have the function go through that point. So we can kind of choose that point 3, 1 to be whatever kind of point we want it to be. Everybody's good with that? So I would choose, that means I can choose any point from the parent function I want, which for sine, I'm going to pick the point 0, 0. Remember where I'm choosing from the points on the parent function. So for sine, I'm picking 0, 0. Remember, 0, 0 is a midline point that's followed by a maximum. I can tell by looking at the y coordinates, right? 1 is the biggest y coordinate, so that's a maximum. 0 is the middle y coordinate. It's in between -1 and +1. So on my resultant function, I'm going to choose 3, 1 also to be a midline point. And I get to choose the kind of midline point I even want it to be. Whether I want to be a midline point that is followed by a maximum or a midline point that's followed by a minimum. It doesn't matter which one. So I'm going to do that. I'm just going to make a note here that I chose that. That you have a freedom there to do what you want. So, what can I say then? Since they're the same kind of midline point, I know that the a has to be positive. Everybody okay with that? Since the x-coordinate of my parent function is a 0, the x-coordinate of my resultant function must be my value for h. And similarly, because the y-coordinate of my parent function is 0, the y-coordinate on my resultant function must be k. So now I have everything I need. To be done. Do I also need to write the cosine version? No, you don't. You just pick one. Could I have done the cosine version? Sure. Does that make the problem a little bit harder? Yeah. Do you want to see why? Sure. So this is just hypothetically. So if we had done cosine, I would have to choose a point from the cosine parent function, so I'd have to choose one of those. Probably the obvious choice would be 0, 1, which is a maximum. So if I make my resultant function then a maximum, again, because it's going max to max, that tells me that the a needs to be 4. Because the x-coordinate is 0 in the parent function, the x-coordinate from the resultant function must be my h. But here's the tricky part. Notice the y in my parent function is not 0. So I have to do a times y from the parent function plus k equal to the y from the resultant function. So to solve that equation, I subtract 4 from both sides to get k as -3. It's this piece here, this crummy piece of algebra here I had to do that I got to avoid by choosing to use a sine function rather than a cosine function in this case. Which again, it's not the end of the world, but if I don't have to do it, let's not do it. You know what I mean? Okay. So that's one way that a problem might look. Let's look at another version of what this might look like. So here it says construct a sinusoid that has a minimum value at 5, 10 and its next maximum at 15, 32. What do I do here? Somehow I have to get my A, C, H, and K all from just these 2 points. Mr. Kulik, all right. My suggestion, let's start by just kind of sketching a picture of what's going on, right? So let's call this our minimum, and we'll call this our maximum. So my graph is going to look like that, right? Everybody agree with that? So I know my midline is going to be halfway in between them, right? So what's halfway in between 10 and 32? 21, right? So this just must be y equals 21. So the k has to be 21. Okay, that's not so bad. And remember, the amplitude is the distance from an extrema back to the midline, right? So how far is it from 21 up to 32? 11. Or how far is it from 21 down to 10? Also 11. They need to be the same. So just checking at both places is a good idea to make sure you didn't make a goofer. Since the amplitude, though, is 11, which we can clearly see, that tells me that the A is either 11 or negative 11. Everybody's okay with that? Okay, so far so good, right? Here's the trickiest piece, is going to be getting the C out of this. So the picture that I've drawn so far, what percentage of a period have I drawn? Should look like half, right? If I were to complete the period, I'd have to continue going back down to a minimum, right? So it looks like from here to here is half a period. Everybody agree with that? Okay. And horizontally, how far is it to go from 5 to 15? That's 10 units, right? So half a period has to equal 10. And then how do I find a period? 2 pi absolute value C. So C is or absolute value C is 10 over pi. So C needs to be either 10 over pi or negative 10 over pi. We always choose the positive version. Okay, so I have two things, or well, really kind of three things left to do. I need to choose whether I want to make a sine or a cosine function. Okay. And then I need to find the sign for A and the value for H. So I have like three things left to do. So if I were to go and pick whether I want to write a sine or a cosine function, which one would I want to pick? Would I want to do a sine function or a cosine function here? I would pick a cosine function. That's going to be the easier one to write. The reason I would do that is because of the kinds of points I've been given. I'm given extrema. I'm giving mins and maxes. Whenever I'm given mins and maxes, I choose, if I have a choice, I want to pick a cosine function. If I'm given midline points or a free point, I would pick a sine function. Everybody's okay with that? And it just because it's going to make finding the H just a little bit easier. All right. So we're picking cosine. Now, from the parent function, we choose cosine. We like to use the point 0, 1, which is a maximum. Now, does it matter which point I pick from my resultant function? Should I pick 510 or 1532? Does it matter? There's not a wrong answer here. You could pick either one. Sure, let's do that. 510. And remember, it tells me that 510 is a minimum. Since I'm going max to min, what does that tell me? The A needs to be negative. And then since the x coordinate on my parent function is 0, it tells me the x coordinate on my resultant function is h. And then I have everything I need. Let's just demonstrate to you why picking cosine here was going to be important. What's going to happen if I pick sine? Why is Mr. Kulik asking me to avoid doing that? He usually has good reasons for that. So if we had picked sine, here's the problem. Is I need to pick from here, and since all I have are extreme points, I have to use either the max or the min from the parent function. Notice that neither of those points, the x-coordinate is 0. Yeah, I know, right? So let's just pick the max here at pi over 2, 1. So if I wanted to pair that with, say, the same 5, 10, I get that the a is still negative, but to find the h, I have to do c times the parent function, or the x from the parent function, plus h equals the x from the resultant function. Which is just kind of like a little bit of a pain, right? Right? This is the step that I get to avoid if I'm just choosing my function intelligently, right? Whether if I'm being careful on whether I want to choose a sine or a cosine function, that's the step that I can avoid. Which again, it's not the end of the world if you have to do that step, but like, why not avoid it if you can? Right? Questions about this process that we've looked at so far? You think you got it? Need some practice now? Yeah, let's stop here. We'll take some time here to do some practice.